September 5, 1906. A man checks into the Hotel Place in Duino on the Adriatic coast of what is now Italy. His name is Ludwig Boltzmann. He is 62 years old. He is one of the most important physicists of the 19th century, though the world does not yet fully know it. He has spent 30 years trying to prove a single idea, not a complicated idea in its essence. The idea is this: disorder always increases. In every system, in every process, in every corner of the observable universe. And the cost of that increasing disorder is something that cannot be returned, recovered, or reversed. He proved this mathematically. He gave it a name. He derived from it a formula, now engraved on his gravestone. His colleagues called it metaphysics. His contemporaries publicly dismissed it as fantasy. And on that September afternoon, while his wife and daughter were at the beach, Boltzmann hanged himself in his hotel room. 3 years later, the scientific community confirmed that everything he had said was correct. You are watching this at a specific moment in the history of a universe that has been dying since it was born. What Boltzmann understood, what he gave his life trying to explain, is the reason you cannot unscramble an egg, the reason smoke rises and never reassembles, the reason the stars themselves will eventually go dark, and the cosmos will arrive at the final state of perfect permanent stillness. There is a name for that final state. I will give it to you now, and I will not explain it yet. Heat death. Keep it. Look at this. You see it? A man who had the proof, the formula, the mathematics, destroyed by the distance between knowing and being believed. What he knew, and what that knowing cost the universe. That is what this is about. You have, at some point, watched smoke rise from something burning. You have never watched smoke descend from the air and return itself to unburned material. Not once, not in your lifetime, not in all of recorded human history, not anywhere in the observable universe. This is not because the smoke lacks the energy to reassemble. The atoms are all still there. Nothing has been destroyed, and yet the return never happens. Boltzmann asked why, and the answer he gave is the reason we now understand time itself as having a direction. Imagine a room divided by a partition. On the left side, all the air molecules. On the right side, vacuum. You remove the partition. The molecules rush into the empty space. Within seconds, they are distributed throughout the room. Now wait a year, wait 1,000 years. The molecules will never, by their random motion, all drift back to the left side and spontaneously recreate the original arrangement. They could. Nothing in the laws of physics prevents it. Each individual collision between molecules is reversible. Run any single collision backward in time, and it looks perfectly normal. And yet the overall system will not spontaneously return to its ordered starting state. Boltzmann understood why. The number of arrangements that look disordered, where molecules are spread throughout the room, vastly outnumbers the arrangements that look ordered. There is essentially one way to have all the molecules on the left side. There are an incomprehensible number of ways to have them scattered. Probability does the rest. The system moves toward disorder, not because disorder is attracted to it, not because any force pulls it there, but because the disordered state is overwhelmingly more likely. A drop of ink disperses in water, not because it is pushed, but because the number of ways to be dispersed so vastly exceeds the number of ways to remain concentrated, that the drift is for all practical purposes inevitable. This drift, this one-way movement from order toward disorder, from concentrated energy toward dispersed heat, is what Boltzmann formalized. His formula, SK log W, describes it exactly. The more microscopic arrangements available to a system, the greater its disorder. And the greater its disorder, the more stable and likely it becomes. Every process that happens in the universe, every chemical reaction, every star that burns, every thought your brain forms, increases the total measure of this disorder. The available energy for doing work decreases. The drift accumulates, and it accumulates without reversal. Here is the second thing I am going to name without yet explaining. If this drift always increases, if the universe is moving irreversibly toward maximum disorder, then where did all the order we see around us come from? Galaxies, life, stars, cities, all of it is spectacularly, improbably ordered. All of it exists against the grain of what the physics demands. How does order exist at all in a universe that is dying of disorder? That question has an answer. It is not the answer you might expect. It comes later. In 1963, a young astronomer named Vera Rubin arrived at Palomar Observatory in California, one of the most powerful telescopes in the world, and was told that the women's restroom did not exist. There was no facility for her. She cut a paper skirt, taped it to the stick figure on the men's room door, and got to work. This detail is not incidental. It is the precise texture of the world Rubin was navigating while she made one of the most significant observational discoveries of the 20th century. Beginning in the mid-1960s, Rubin turned her attention to the velocities of stars at the outer edges of spiral galaxies. Not the centers, the edges. The outer regions, where stars orbit far from the galactic core. By every calculation, those outer stars should move more slowly than stars near the center. The same way the outer planets of our solar system orbit the Sun more slowly than the inner ones. Gravity weakens with distance. Orbital velocity decreases accordingly. This was not a hypothesis. It was a mathematical certainty derived from Newton, confirmed across centuries of observation. Rubin's measurements showed something that did not fit. The outer stars were moving just as fast as the inner ones, sometimes faster. The rotation curves were flat when they should have been declining. She checked her instruments. She checked her calculations. She measured different galaxies. The result was the same each time. She later described the experience this way. She had expected to find what everyone expected to find, and instead found something that made no sense within the framework of everything she had been taught. The data was unambiguous. The implications were enormous. And the first responses from colleagues were, in her own words, that she must have made an error. She had not made an error. The only explanation that survived scrutiny was this. The galaxies were embedded in vast halos of matter that could not be seen. Matter that did not emit light, did not reflect it, did not interact with electromagnetic radiation in any way detectable by any instrument then or since. Its presence was legible only through the gravitational effect it exerted on the stars we could see. The way a current is known not by the water itself but by the displacement of everything moving through it. Dark matter. It accounts for approximately 27% of the total energy content of the universe. We have never directly detected a single dark matter particle. We know it exists because Vera Rubin stood at a telescope in an observatory that had no bathroom for her, and measured what the universe was actually doing rather than what it was supposed to do. She was nominated for the Nobel Prize for years. She died in 2016 without receiving it. What she revealed is this: the universe we thought we understood, the universe of stars and gas and light, the universe visible to every instrument we have ever built, is the minority. The bright matter we can observe constitutes less than 5% of all that exists. The rest is dark. Either dark matter or something stranger still, a force driving the accelerating expansion of space itself. That force connects directly to the word I gave you at the beginning. Dark energy is perhaps the most significant fact about the universe that we cannot explain. What we know is this: it permeates all of space, it does not dilute as the universe expands, and it is causing that expansion to accelerate. Galaxies beyond a certain distance are already receding from us faster than the speed of light. As the universe ages, that threshold draws closer. Galaxies that are currently visible to us will eventually cross the horizon of causal contact. Their light will never reach us. They will, from our perspective, simply cease to exist, not because they are gone, but because the space between us and them will grow faster than any signal can cross it. The night sky is growing darker, not metaphorically. It has been happening since the first galaxies formed. Every billion years, more of the universe becomes permanently unreachable. But set the expansion aside. Come back to Boltzmann. Stars are not permanent. They are engines that burn fuel, hydrogen fusing into helium, helium into carbon, carbon into heavier elements, and they do so at enormous cost to the ordered energy available in the universe. Every star that burns is spending that currency. Every photon radiated into space is heat that will never return to useful work. The Sun has approximately 5 billion years of fuel remaining. When it exhausts that fuel, it will expand, cool, and collapse into a white dwarf, a dense remnant slowly radiating its remaining heat into the void. Over trillions of years it will cool to match the temperature of the surrounding universe. At that point it becomes a black dwarf, a cold dark object indistinguishable from the void it occupies. This will happen to every star, each one burning its fuel, dispersing its heat and then going dark. The last star will exhaust its fuel somewhere between 100 trillion and 1 quadrillion years from now. After that, the universe will contain only stellar remnants, black holes, and the cold background radiation filling all of space. The black holes themselves will eventually evaporate through a quantum process first described by Stephen Hawking in 1974, a slow radiation of energy that will require an almost incomprehensible duration to complete. The largest black holes will finish this process in approximately 10 to the power of 100 years. After that, there is no more available energy, no more stars, no more heat differentials to drive any process. No more work to be done anywhere. The universe reaches a state of maximum disorder.
Every region of space has the same temperature, fractionally above absolute zero. Nothing happens. Nothing can happen. No process is possible, because all processes require a difference in energy, and no differences remain. This is heat death, not a dramatic explosion, not a collapse, a stillness, a final permanent equilibrium, from which nothing can emerge, and into which nothing new can enter. Now I can close the first loop.
If the drift toward disorder is irreversible, if the universe is driven without exception toward its cold and permanent end, how does any of this exist? How did galaxies form? How did stars ignite? How did planets accrete from dust, and oceans form from ice, and cells emerge from chemistry, and brains develop from cells, and you arrive at the point of watching this? The answer is not that the physics was overcome. It was not suspended or reversed or temporarily defeated. The answer is that order is possible locally when disorder increases globally. A refrigerator makes things cold inside. It does not violate thermodynamics. It simply exports its disorder to the room. The heat expelled from its pack exceeds the order created inside it. The kitchen becomes warmer. The total disorder of the system increases. The interior of the refrigerator is ordered at the cost of the disorder of everything around it. Life operates on exactly this principle. Every living organism takes in low disorder energy, sunlight, food, chemical gradients, and expels high disorder waste, heat, carbon dioxide, water vapor. The organism maintains its internal structure at the cost of increasing the disorder of everything around it. Life is not a violation of the second law. Life is one of its most efficient expressions. The sun is the original source of the low disorder energy that makes life on this planet possible. And the sun is itself drawing on the ordered initial conditions of the early universe, a state so precise and improbable that physicists still argue about what produced it. The entire history of complexity, galaxies, stars, planets, organisms, civilizations, is the process by which the universe spends the ordered energy it was given at the beginning. We are not fighting the physics, we are its expression. Every thought you have, every structure you build, every life that grows and creates and connects, it all happens in the window between the ordered beginning and the disordered end. The universe permits complexity in the process of becoming simpler. We are the complexity it permits. Boltzmann understood this in its mathematical form. What he could not see, what no one in 1906 could have seen, was the cosmic scale at which his formula applied. He was describing gas molecules in a room. He was also describing the fate of everything that will ever exist. Return now to September 5, 1906. A man in a hotel room in Duino who has spent 30 years being told that his life's work was fantasy, that atoms were metaphysics, that thermodynamics was already settled and he was contributing noise. He did not live to see Perrin's 1908 experiments, which confirmed the existence of atoms beyond reasonable doubt. He did not live to see Einstein's 1905 paper on Brownian motion, which used atomic theory to explain the observable jittering of particles suspended in liquid. He did not see his formula inscribed into scientific consensus. His daughter found him. She had been at the beach. The formula on his gravestone is SK log W. It says in mathematical shorthand that the disorder of a system S equals Boltzmann's constant K multiplied by the natural logarithm of W, where W is the number of microscopic arrangements that correspond to a given macroscopic state. More arrangements, greater disorder. The universe moves toward the state with the most available arrangements, always, without exception, from the moment of its beginning to the moment of its final stillness. A man who understood this more clearly than almost anyone who had ever lived could not hold on long enough to see it confirmed. What was lost in that hotel room was not only a life, it was the certainty in the final years of that life that he had been right. His gravestone carries the proof. The universe carries the process. There is a certain kind of quiet that comes from understanding this clearly, not despair, something different from despair. The universe did not begin in disorder. It began in a state of remarkable improbable order, a state so precise that its origin remains one of the deepest open questions in all of physics. And from that ordered beginning over 14 billion years it has produced you, and the people near you, and every city and forest and ocean on this planet, and every planet anywhere that has ever harbored anything we might recognize as structure or life or meaning. All of it is the spending of the original order. All of it is the universe doing what Boltzmann said it must do. We are early. The era of stars, our era, occupies a vanishingly small fraction of the total timeline of the cosmos.
The universe is old, but it is not nearly as old as it will become. The process has an almost incomprehensible distance left to run. We exist in the window when energy is still available, when stars are still burning, when the differences that drive all processes have not yet smoothed themselves into equilibrium. In this long improbable meanwhile, the universe produced everything that has ever mattered to anyone. What Boltzmann gave us is not only a description of decay, it is a description of why you are possible in a universe governed by physical law. The formula says that order requires a cost and that the cost is paid in this order. We are the order. The expanding, cooling, darkening universe is the cost.
The hotel in Duino still stands. The Adriatic still reflects the light of a star that is slowly, steadily converting its hydrogen to helium, dispersing its heat into space, spending the order it was given at the beginning of everything. A man who understood this could not find in 1906 enough reason to stay. I have thought about that often, about what it means to possess a true understanding of something and be met with incomprehension, about the distance between knowledge and recognition, about how much was lost in that room. Not only a life, but the last years of a life lived without the confirmation that it had been right. His gravestone carries the proof, the universe carries the process, and you watching this are somewhere inside both.